Have you ever just stood there watching honey slowly ooze out of the bottle? Or tried to get ketchup to come out and had to give it a good whack? Well, it turns out there's a hidden property in all liquids that explains this. So let's dive in and uncover the secrets of how stuff flows. Okay, let's start with a puzzle we've probably all seen at the breakfast table. You take the syrup out of the fridge and it's super thick, super slow. But you pop it in the microwave for a few seconds and suddenly it pours like a dream. What is going on there? This isn't just a kitchen question. This is a real-world problem that engineers run into all the time. Take a guy named Abe Rosenberg, for example. He was in his lab doing what he thought was a simple experiment with water. But his results, well, they were all over the place, and he had no idea why. So Abe was pumping water through a filter, carefully measuring everything. The flow rate, the pressure. He expected his measurements to line up nice and neat on a graph. But they didn't. Not even close. He was doing everything by the book, but some mysterious hidden variable was totally messing up his experiment. And then he had this little hunch. He noticed that during his tests, the water's temperature was changing, but only by about 10 degrees Celsius. That's not a lot, right? Could such a tiny shift in temperature really be the cause of such a massive problem? The answer to Abe's puzzle and our syrup question boils down to a property we can just think of as a liquid's thickness. Or maybe it's internal stickiness. It's the reason stirring a jar of molasses feels completely different than stirring a glass of iced tea. Now, scientists have a fancier word for this thickness, and that word is viscosity. It's basically a measure of how much a liquid fights against flowing. You can kind of think of it like friction. So a liquid with high viscosity has a ton of internal friction, which makes it move really slowly. And here's a super simple way to see it. On one hand, you've got water. It has low viscosity, we'd call it thin, and it flows super easily. On the other hand, you have honey. It's got super high viscosity. It's thick, and it really resists flowing, which is exactly why it's so darn slow. Okay, so liquids have this thing called viscosity. Got it. But how does temperature get mixed up in all of this? Let's connect the dots and get back to Abe's mysterious experiment. I want you to imagine that inside any liquid, there are zillions of tiny little molecules, and all of these molecules are attracted to each other. It's almost like they're all holding hands. It's this hand-holding, these connections, that create that internal friction we call viscosity. So what happens when you heat up a liquid, like our syrup? Well, you're giving all those little molecules a bunch of energy. It's like turning up the music at a party. They start to wiggle and jiggle and dance around so much that they can't hold on to each other as tight. They loosen their grip, that internal friction goes down, and voila, the whole liquid can flow way more easily. And here it is. This is the key to Abe's entire experiment. For water, a temperature change of just 10 degrees Celsius, exactly what he was seeing, can change its viscosity by a whopping 20%. That is a huge change from what seems like a really small shift in temperature. And just like that, the puzzle was solved. The reason Abe's data was all over the map was because the stickiness of his water was secretly changing the whole time, every single time the temperature moved even a little bit. In a way, he wasn't even testing the same liquid from 1 minute to the next. So this isn't just some weird problem for scientists in a lab. Understanding and controlling viscosity is actually incredibly important for tons of things that we use every single day. Seriously, you see it everywhere once you start looking. Engineers have to design engine oil with the perfect viscosity so it protects your car's engine, whether it's freezing cold or super hot outside. The viscosity of concrete is critical to make sure it can be pumped at a construction site. It's what makes makeup feel smooth on your skin. And yep, it's why ketchup is designed to be thick in the bottle, but flow when you shake it. Okay, so we've got the rule down. Heat makes liquids less sticky and helps them flow faster. Simple, right? Well, what if I told you there's a paradox out there that seems to completely break this rule? Yeah, get ready for a real head-scratcher. Believe it or not, this is a real thing, and it's known as the Mpemba effect. The idea that hot water could freeze solid before cold water. Well, people have been noticing this for literally thousands of years. The philosopher Aristotle was writing about it way back in 350 BC. So what's going on? Well, scientists have a few different theories, but no single answer. Maybe it's because some of the hot water evaporates, so there's just less water to freeze. Or it could be that currents in the hot water help it cool faster. Maybe heating it removes gases that were dissolved in it. It's even possible that cold water is more likely to do this weird thing called supercooling, where it stays liquid even when it's below its freezing point. But here's the absolutely amazing part. After thousands of years of people noticing this and countless modern experiments, scientists still don't actually agree on why it happens. As the National Institutes of Health says, there is no universally accepted explanation. It's still a mystery. So, from a simple bottle of honey to a tray of ice cubes, the world of liquids is just full of this fascinating science. It really shows us that even in the most ordinary, everyday things, there are these deep, amazing puzzles just waiting to be solved. Makes you wonder, right? What everyday mystery will you notice next?